Hi guys, here we are going to discuss the most important theorem of mechanics, which is lambda mu theorem. And basically it tells us about about the resultant of two concurrent forces. If there are two concurrent forces and they are acting on a certain point, then their resultant can be found out by some certain rule, and that rule is what? Lambda mu theorem. The statement says if two concurrent forces are represented by OA, lambda OA and mu OB, then the resultant can be given by lambda plus mu OC, where C divides AB such that AC ratio CB equals to mu ratio. You can have a different definition because there is a slight difference in the definitions which exist in different books, but it is also a, no, a valid definition. So let's understand it by the help of diagram. So here is a diagram which tells you that there is a triangle OBA, and it has three sides, and there is also a line which divides this triangle into two other triangles. But if you see it from the concept of forces, then you see that there are two forces. One force is OB and the other force is OA. A force is acting along OA and one force is acting along OB, and their resultant is given by this central line, which is to which I have written R. So we are interested in finding out this R. This R is actually the resultant of these two forces, and I have represented this force by mu OB and the other force by lambda OA. So if you see this diagram, you can make two equations from this diagram. See here. Here you have if you see OA, then OA equals to OC plus CA, and OA. So OA is here, and OA equals to OC plus CA. And the other force OB can be resolved into the two components, which are OC plus CB. OC plus CB. CB. I am. Let me just tell you that I am moving from here to here. The direction of this force CB is this, and the direction of this force is CA, which is from here to here. So I have resolved these two forces into their components, and now I am going to use these equations to find out the R. From here, you have to multiply the first equation with lambda and the second equation with mu, and you will have this sort of thing like this. Now I have multiplied the first equation with lambda here and the second equation with mu here. So I have got lambda OA equals to lambda OC plus lambda CA, and mu OB equals to mu OC plus mu CB, this thing. So the other thing that we will do is to add both of these equations. Adding both of these equations, you get lambda OA minus mu OB equals to lambda OC plus CA, lambda CA plus mu OC plus CB. Okay, I can't. Okay, fine. So from here, what you can do, you can you know that you can take this lambda plus okay, you can take this OC common from lambda plus mu. So if you do it, if you take lambda OC common out of these, you will have this thing, and separately the thing that you will have is lambda CA plus mu and CB. Here one thing that I would like to tell you, that this CA and this CB are actually equal and opposite in direction. So that is why you will only have this side lambda plus OC equals to this side, and this will cancel with each other, and the reason is that actually your lambda ca equals to minus mu cb, and this thing is equal to minus lambda ac. uh, Both of these, in the diagram we shown that this was your cb and this was your uh, actually this was yeah cb, and this is your ca. So both are opposite in direction but equal in their and they equal in weight, equal in magnitude, so that is why they cancel each other, and just left with this lambda plus mu oc, and here hence here it is proved. So with this the theorem completes. If we see it, we started from these two equations, then we multiplied with the first equation with the lambda and the second equation with mu. Then we added both of the equations, and this step was a little bit you can say conceptual. In this step we cancel these magnitudes, and we finally got the equation, and we give the reason, and it was all.